The formula for calculating diesel generator set rating is as follows: diesel generator set rating equals total power requirement divided by power factor times 1 divided by standby load factor. Total power requirement is the sum of all electrical loads in the facility, considering load and demand factors. Power factor is the ratio of real power to apparent power, typically ranging from 0.8 to 1. Standby load factor is the ratio of the actual load to the maximum load capacity of the diesel generator set, typically ranging from 0.5 to 0.8. Here's a sample calculation. Given voltage level 400 volts, power requirement 2000 kilowatts, load factor 80%, demand factor 70%, power factor 0.9, and standby load factor 0.6, we can calculate the required diesel generator set rating. Step 1. Calculate the adjusted power requirement. Adjusted power requirement equals power requirement divided by load factor times demand factor. Adjusted power requirement equals 2000 kilowatts divided by 0.8 times 0.7. Adjusted power requirement equals 3571 kilowatts. Step 2. Calculate the diesel generator set rating. Diesel generator set rating equals adjusted power requirement divided by power factor times 1 divided by standby load factor. Diesel generator set rating equals 3571 kilowatts divided by 0.9 times 1 divided by 0.6. Diesel generator set rating equals 6285 kilowatts. The diesel generator set rating can be adjusted depending on factors such as reliability requirements and operating conditions. It is recommended to consult with a qualified electrical engineer for precise calculations and equipment selection. To elaborate further on these concepts, let's delve deeper into each component of the formula. The total power requirement is a critical factor. It represents the aggregate of all electrical loads within a facility. This includes lighting, machinery, HVAC systems, and any other equipment that draws power. When determining the total power requirement, it's crucial to account for both the load factor and the demand factor. The load factor is the average load over a specific period divided by the peak load during the same period. It essentially reflects how efficiently the electrical system is being utilized. A higher load factor indicates more consistent usage, while a lower load factor suggests that the system experiences significant peaks and valleys in demand. The demand factor, on the other hand, is the ratio of the maximum demand of a system to the total connected load of the system. It acknowledges that not all connected loads will operate simultaneously at their full capacity. For instance, a building might have a total connected load of 1000 kilowatts, but the maximum demand at any given time might only be 700 kilowatts, resulting in a demand factor of 0.7. Accurately assessing both the load and demand factors is crucial for avoiding oversizing the diesel generator set, which can lead to increased costs and reduced efficiency. Undersizing, on the other hand, can result in the generator being unable to meet the facility's power needs during peak demand. Next, let's consider the power factor. Power factor is a measure of how effectively electrical power is being used. It's the ratio of real power, measured in kilowatts, to apparent power, measured in kilovolt amperes or kVA. Real power is the power that performs actual work, while apparent power is the total power flowing in the circuit, including both real and reactive power. Reactive power is caused by inductive loads, such as motors and transformers, and it doesn't contribute to useful work. A power factor of 1 indicates that all the power being supplied is being used effectively. A power factor less than 1 indicates that some of the power is being wasted as reactive power. Power factor is typically expressed as a decimal between 0 and 1. With values closer to 1 being more desirable. A typical power factor for industrial facilities ranges from 0.8 to 0.9. If the power factor is significantly lower than this, it can be improved by installing power factor correction capacitors. Failing to account for power factor in the diesel generator set calculation can lead to underestimation of the required generator size. The diesel generator set must be sized to handle the total apparent power, not just the real power. Finally, let's discuss the standby load factor. The standby load factor, as mentioned earlier, is the ratio of the actual load to the maximum load capacity of the diesel generator set. It reflects how heavily the generator is being loaded during operation. A standby load factor of 1 indicates that the generator is operating at its maximum capacity, while a standby load factor of 0.5 indicates that the generator is operating at half its maximum capacity. The standby load factor typically ranges from 0.5 to 0.8. A lower standby load factor can indicate that the diesel generator set is oversized for the application, while a higher standby load factor can indicate that the generator is being pushed to its limits. It's important to select a diesel generator set with an appropriate standby load factor to ensure both efficiency and reliability. Now let's elaborate on the steps involved in the sample calculation. In step 1, we calculate the adjusted power requirement by dividing the power requirement by the product of the load factor and the demand factor. This adjustment accounts for the fact that the facility's actual power demand is typically less than its total connected load. In the example provided, the power requirement is 2000 kilowatts, the load factor is 0.8, and the demand factor is 0.7. Therefore, the adjusted power requirement is 2000 kilowatts divided by 0.8 times 0.7, which equals 3571 kilowatts. In step 2, we calculate the diesel generator set rating by dividing the adjusted power requirement by the power factor and then multiplying by 1 divided by the standby load factor. This calculation accounts for both the power factor and the standby load factor, ensuring that the selected diesel generator set is capable of meeting the facility's power needs under a variety of operating conditions. In the example provided, the adjusted power requirement is 3571 kilowatts, the power factor is 0.9, and the standby load factor is 0.6. Therefore, the diesel generator set rating is 3571 kilowatts divided by 0.9 times 1 divided by 0.6, which equals 6285 kilowatts. It's important to note that this is just a sample calculation and that the actual diesel generator set rating may need to be adjusted based on specific factors such as reliability requirements and operating conditions. For instance, if the facility requires a high degree of reliability, it may be necessary to select a diesel generator set with a higher capacity than the calculated value. Similarly, if the diesel generator set will be operating in harsh environmental conditions, it may be necessary to direct the generator's output to account for temperature and altitude. It is always recommended to consult with a qualified electrical engineer for precise calculations and equipment selection. An electrical engineer can assess the facility's specific power needs, taking into account all relevant factors, and recommend the most appropriate diesel generator set for the application. They can also provide guidance on installation, operation, and maintenance to ensure the generator's long-term reliability and performance. Furthermore, selecting a diesel generator set also involves considering several other factors beyond just the kilowatt rating. These factors include the voltage level, the frequency, the type of fuel, the noise level, and the emissions. The voltage level of the diesel generator set must be compatible with the facility's electrical system. Common voltage levels for industrial applications include 480 volts, 208 volts, and 120 volts. The frequency of the diesel generator set must also be compatible with a facility's electrical system. The standard frequency in North America is 60 Hz, while the standard frequency in Europe is 50 Hz. The type of fuel used by the diesel generator set is another important consideration. Diesel fuel is the most common fuel for diesel generator sets, but natural gas and propane are also used in some applications. The noise level of the diesel generator set can be a concern, especially if the generator is located near residential areas. Diesel generator sets are typically equipped with sound attenuators to reduce noise levels. The emissions from the diesel generator set are also an important consideration, especially in areas with strict environmental regulations. Diesel generator sets are typically equipped with emission control systems to reduce emissions of pollutants such as nitrogen oxides, particulate matter, and carbon monoxide. In addition to selecting the appropriate diesel generator set, it's also important to properly install and maintain the generator to ensure its long-term reliability and performance. Installation should be performed by a qualified electrician and should comply with all applicable codes and regulations. Regular maintenance is also essential for keeping the diesel generator set in good working order. Maintenance tasks include changing the oil, replacing the filters, and inspecting the engine and generator components. In summary, calculating the appropriate diesel generator set rating is a critical step in ensuring a reliable and efficient power supply for any facility. By carefully considering factors such as total power requirement, power factor, standby load factor, and other relevant factors, and by consulting with a qualified electrical engineer, it is possible to select the right diesel generator set for the application and to ensure its long-term reliability and performance. Let's reinforce the key takeaways from this explanation. Firstly, the diesel generator set rating is calculated using the formula diesel generator set rating equals total power requirement divided by power factor times 1 divided by standby load factor. Secondly, the total power requirement is the sum of all electrical loads in the facility, considering load and demand factors. Thirdly, a power factor is the ratio of real power to apparent power, typically ranging from 0.8 to 1. Fourthly, the standby load factor is the ratio of the actual load to the maximum load capacity of the diesel generator set, typically ranging from 0.5 to 0.8. Fifthly, a sample calculation was provided to illustrate the application of the formula. Sixthly, it is important to note that the diesel generator set rating may need to be adjusted based on specific factors such as reliability requirements and operating conditions. Seventhly, it is always recommended to consult with a qualified electrical engineer for precise calculations and equipment selection. Finally, selecting a diesel generator set also involves considering factors such as voltage level, frequency, fuel type, noise level, and emissions, as well as proper installation and maintenance practices.